So the reactions of the esters, the hydrolysis of the esters in particular, is the reverse of the esterification reaction, whereas in the forward direction we took a carboxylic acid and an alcohol and we made the ester and water. That is acid catalyzed, but we can do the reverse of that, so we can take an ester, add water to it and get back our carboxylic acid and our alcohol. Again, that is catalyzed by an acid as well. Okay, so just to really have a look at that reaction, and again I want to go to this board here really first. So here's the ester, and what I want you to remember is that we're going back. If you remember in the forward reaction where we made the ester, we removed water. So let me just refresh your memory of that one. So we did, for example, ethanoic acid, and then methanol. If you remember the cutting that we did, we cut it there and here. And essentially what we did was we removed the water from it. So let's remove that water there. And what we ended up with was that ester there, and there's the water that we removed down the bottom there. What we're doing essentially is going back. We're going to put the water in. It's the exact opposite of what we've just done. So if I get rid of all of this, and then I'll do it on the example that I've got at the top. So when I'm looking at this molecule, then what I'm doing is I'm cutting it at that point there. And if you remember, I've said to you, we always cut between the carbonyl and the oxygen, whether it's the carboxylic acid, whether it's the ester, or whether it's, which we'll come to a little bit later on, any of the other derivatives of the carboxylic acids. So we cut it at that point there. And what I'm going to do is I'm going to cut it like that. So there's our carboxylic acid that we've cut. Remember, we need to put water back into here. So in putting our water back on, the OH goes on there from the water, and the hydrogen goes back on here from the water. So what we've ended up with is our carboxylic acid and our alcohol back from our ester by putting the water back in. And that is highlighted here using the acid hydrolysis. So sulfuric or hydrochloric has to be aqueous because we need that water. The acid, remember, is just a catalyst. So we're putting water back in. So if you remember, we are cutting it at that point there. We put an OH back on the carboxylic acid, and we put a hydrogen back onto the alcohol. Okay. So there's a specific example that is made there, and again, it all kind of connects really. That if we cut this at that point there, remember this bit forms the alcohol, which is what we do the first name. So the ethyl becomes ethanol, and then this part here, which is the bit that we named second, that's the propanoate, which forms the propanoic acid. And I hope you can see here that we've got OH there, which would have come from that, and then the hydrogen over here, which would have come from that point there. So that's the acid hydrolysis of the carboxylic acid. It is literally the reverse of the esterification reaction. Okay, and I think I'll stop that one there.